Good evening, everyone. Today, I have Arnold with me, and we will be going through Python tutorials. And this is going to be about
Yes, indeed.
variables. Yes, about variables and data types in Python. Yeah, this chapter serves as a foundational guide to how Python handle information using variables and simple data types, which are string and numbers. Yeah. Here is a concise summary of the key concepts. Variables. It's like a label for values. Mm. Inside the instead of thinking of variables as a box, Python treats them as labels that reference a specific value. Yeah. So
Yes,
basically, unlike other programming languages, Python doesn't store the value inside like a box. What it does is it labels that name of that variable to a specific reference in point. Yeah. To a
yes,
yeah. So the dynamic nature. You can change a variable's value at any time. Python allows keep Python always keeps track of most recent arguments. So assignment. So basically, if you assign something in Python, it keeps in the latest um, version of what you've stored inside. Yeah. And in naming the
great.
variables, there are some rules involved in it. You can use only letters, numbers, and underscores.
Yeah,
You cannot use in
yes,
a dollar sign, exclamation, you know, times, plus. No, we don't use all of those. And you must start
no,
with a letter or underscore. Those are accepted. Yeah, and we'll see some examples of those as well. No spaces allowed.
yeah,
Yes, no spaces allowed in between naming of variables. But you can put an underscore in between to name it. That's perfectly fine. You can use underscore to separate, names. Yeah, you can avoid using keywords like print. You can use any name, but it shouldn't be specific keywords like the for, the in, not. Those are the special keywords that are not allowed to be used in. Um, you can use short, descriptive, lowercase names such that other programmers can also read and understand easily what you're trying to assign to a specific. Yeah. So we also have strings. Strings working with text. A string is a series of characters inside a single quote or a double quote. So this is how a string is created. Anything that is in a single quote or a double quote is going to be a string. Now we have methods. Methods are actions um, performed on data. So basically, methods are like functions that are built in for the specific data type, of which we're talking about a string type now. So now we have the title method, which capitalizes the first letter in each word. Yeah. So we have a title method. Aside the title, you can also use a capitalized method as well. It's also the as if you don't want to use the title method. The title works most of often nice for everyone. Yeah, we also have the upper and the lower. This changes it changes text to all caps, which is the upper. It changes to all caps and lower, which changes to all lowercase. Yeah. And we have the f of string, which is the latest way of encapsulating your string such that you can implement variable names within your string and print it out nicely. Okay, it's used to invert variable values into string by placing the f before the quote and it uses braces. Yes, as you can see over here, all of this is a string, but we have the f of string up in front here that allows us to use the quote, the braces, the curly braces in here. We can see over here. So we also have what we call white spaces in Python. White spaces are just like empty lines, but white spaces also helps for we the programmers that it helps us to read it nicely. But otherwise, the code itself
Yeah.
can ignore all of the white spaces. Now we have this symbol here is a backslash. Is a backslash or forward slash? I think back yeah, backslash.
It is a backslash. Yeah.
Yeah, backslash T. So this what it does here is it adds tab. Yeah, it's more like pressing the tab on your keyboard or pressing space but 4 times. Yeah, and we also have
Yeah.
the in keyword that allows you to go into a new line. So that's what those are all white spaces that allows we the programmers to structure our code nicely. And also
Yeah.
basically that's it. And we have stripping. Luckily for us, we're able to do special things which are called methods. We could do to the string objects. Oh yeah. So basically we could strip the right part of a string. For instance, if you type something here in a double quote, it's going to be a string. You might end up leaving some white spaces in front of the text. You can eliminate all of those using the R right strip. You can also remove all the spaces on the left side using the left strip, which is the L strip. Or the simpler way is just to right strip, which strips both sides. Yeah, to remove unwanted space from the ends. Yeah, so that's it. And we also do have a prefix. Remove prefix. You type in what exactly you want to remove after putting in your text in here. So basically, if you want to remove a prefix, maybe from here, I say hello world, and you say remove prefix, you just put this dot after the string. Then you write remove prefix. Then you specify what exactly you want to be, what you want exactly to be taken out. So type in hello in there. It's going to take out the hello and leave the rest in there. Now we also have remove suffix, which obviously does the opposite. It does the removing of the back. So it sets from the backward and then remove whatever you type in here. It's gonna trim it out nicely for you. Yeah. Now we usually use the remove prefix and remove suffix for websites addresses. You know. Yeah. And we also do have a number as a data type in Python. We do have integers and floats, which are subsections of the numbers. Yes, for integers are our normal counting numbers. Yes, it could be negative, it could be positive, but not decimal. But we also have floats. Float is what allows us to use decimals in Python. So Python categorizes numbers into two types. You have the integers and the floats. Yeah. So whole numbers, as you can see over here, supports standard method. Yeah, it supports you using addition, subtraction, multiplication, division, and exponents. Actually, you can use two stars, which two of this is can take it to exponent, or you can yeah. Eventually, as time goes on, we will use the import math, and then we'll be using some of the math modules to take things to exponents using the power method. Okay. But yeah, that is it for now. But in some different other programming languages, they use what do you call it? Caret sign, which looks like an arrow pointing up.
Is
Yes, to change things to exponent. That's fine. And then we have floats, another number with decimal points. Yes, that is so when you run this here in your on our shell, we're gonna end up having a decimal, and that is a float. Yeah. So basically we could try that in our shell next to us. That will be fine. Okay, let's use this one. Let's try this. So let's type in 4 divided by 2. So you see our result here is a float. You can see it in decimal. Mixing an integer and a float will result in a float. Yeah. So if you try to add maybe 44 plus 2,7, let's say 2,7, yeah, it's definitely going to result in a float. Float is always a decimal. So that is it. And for readability, you can also use underscore for large numbers. Actually, what Python does is it ignores all of this underscore here. So you can also try it here. Let's say, let's put in a number. Let's say we wanted to print. Okay, because we're in the shell, there's no need to start writing by not print and then let's start with a print. Let's try this. So you can see it over here. What Python does is it ignores that underscore here. The purpose of putting an underscore is for we the programmers, for us to easily read what is going on in here. Sometimes if the numbers are too cramped together, it's very hard for us to see. We might end up missing a 3 or a 2, depending on how crowded it looks. So for readability, it's nice to put in underscores in long numbers. Okay. So,
Yeah.
and we also do have what we call constants. Constants are things that you don't want to change within your program. Yeah. Um, Luckily for us in Python, we don't have to declare like var, let, const, but
No.
Python has a formal constant type, but programmers use all caps to signal that a variable should never be changed. Yeah, that is a nice way of um, telling other programmers that you intend not to change the content of something. Yeah. But if you still change the content, it's still going to change. But it's okay. Let's see. Let's try this. Um, let's create a variable called sample, and let's assign 222 to it, and let's print. Let's say sample. So it tells us what it is. Let's try to change it to C. It's going to change. But the main reason why we say we should encapsulate it, make it all caps, is to tell other programmers that this wasn't supposed to change. So in case you're debugging and you realize that the content of it has changed, that means there's something not okay over there. So that helps you to debug properly and you dive down to know why it changed and what to do not to make it change. So all caps just to help you and other programmers know that something was never meant to be changed. Okay. So we have best practices in Python, which we call the PEP 8. Yes. So name error, usually caused by misspelling and variable names or using variable before defining it. Yes, those could also cause errors. So usually if we misspell a word, but maybe after typing sample, then I try to use that variable. But this time around, instead of saying sample, I say sample. And it tells me there's an error over here. It doesn't know this over here. You see, the name sample is not defined. Do you mean sample? So it is trying to ask me, do I mean this instead of that? So those are some of the common mistakes that could happen. And we can see that the traceback, as we spoke of in chapter 1, we can also see it here. This whole thing here is the traceback. It helps us trace back to the
Yeah.
root of our problem. Yeah, so that is misspelling. Actually, Python is I think every programming language is case sensitive. So we must be very careful of the naming. And the naming has to make sense so that other programmers wouldn't um, be confused when they see a word like this. And yeah, and also when other people try to import your code, they wouldn't be facing problems. Maybe they spell things correctly, but looking in your file, things are spelled wrongly. So spelling is very important. Or using variables before they are defined. For instance, here I haven't defined anything called apple. But let's try to get what apple is. Let's see. Let's say apple. Nothing in apple. And now let's try to give it some apple. That's a nice name. Let's say apple should be. Let's say yeah, string. String. Love apple. Let's give it a better name. Let's say message. Yeah. So I love eating. So, but in the case whereby I didn't assign anything inside message, it will give me traceback that the name message is not defined. So you see it. So it's gonna look through the previous things and ask me, do I mean this or that in place of what I'm trying to get in? But now if I try to run message, um, it's gonna print me what the message says. See, I love eating apples. Yeah. So no, that is the whole thing about um, Python variables and data types. Yes, and then we also have syntax errors. Apart from naming errors, we have syntax errors. This occurs when Python doesn't understand the structure of a code. Just like in English language or any language, there's a structure of a sentence. I cannot say is eating. No, no, no. I have to say I am eating. That is going to make everyone understand what is it. That's why even in programming language, there's a structure of a sentence, which is called a syntax, which we have to obey to avoid certain funny errors. Yeah. An example: forgetting to close a quote can also cause error. Let's try this out. Let's say print happy. Let's say print happy. But instead of closing it, I just do it like this. Now, instead of putting in the bracket, instead of closing the quotes and then putting the brackets close, it tells me over here syntax error. So that is the syntax error it's talking about over here. So it occurs when Python doesn't understand the structure. So basically, that's the structure we are breaking. And also, we have something called comment. Comment is using the hashtag symbol to write a note in plain text.
Yeah.
This helps.
Yeah.
Yeah, this helps explain why and how your code works for yourself and other programmers as well. So everyone easily understand what you're trying to mean by the code you wrote. Sometimes you might write a code today, but maybe 5 years down the line, you come back and you may not understand why you wrote what you wrote, how you wrote it. So looking at your comments that time is going to help you understand the process, why you were thinking, how you were thinking by that time. So the comment is going to help you do that. And we do have what we call the Zen of Python. Yes. So the Zen of Python, we can try to read what it's talking about. Zen of Python. So this is what a Zen of Python is. These are the this beautiful is better than ugly. So it's nice to write beautiful, nice, simple code instead of trying to be complicated. Yeah. It says what? Excellent is better than implicit. Explicit is better than implicit. Oh, yeah. Simple is better than complex. Yeah, as we can see. Yeah, and flag is better than nested. Yeah, sometimes we flag things before we try to use them instead of nesting it directly into your um, function or the for loop or whatever. Yeah. So basically, this is if you want to get the design, the Zen of Python, you just import this. Yeah. Then you find the Zen of Python in the. It's a set of guiding principles for writing dynamic code, emphasizing basic writing, readability, and elegance. So to access it via import this. So that basically that is it's about variables and data types. But yeah, but otherwise we have other data types, but we will delve into that maybe another time. Yeah. Thank you guys for your time, and thank you Arnold as well for having for being here. Okay. So let's also look at the other data types in Python. So when we see over here, we have numeric data types, or we also do have complex data type, whereby we have our real number and then we have our imaginary. And then normally in math, we use I for the imaginary, but in Python, we use the letter J because letter after I, we go to J in the alphabetically order. We chose I so we don't confuse it with one in Python. And we also have the sequence type, which is the list. We have tuples, which are immutable. We have range, and those are all also data types in Python. We also have maps as well, with like a dictionary. It's also a data type. We have sets. We also have frozen sets, and we also have binary types, which are bits and bit array, and all of this, including Boolean. Boolean is our true or false. Those are also data types. But yeah, we're focusing on the simple ones, which is the numbers, which is divided into int and float types. We also have strings. Yeah. So basically, that is it for um, Python variables and data types. Thank you all for your time. Yeah. Thank you so much, Arno.
Thank you, man.
Yeah. So basically, that is it for. Yeah.
Awesome.
Okay.